Hello, we are Senior Design Team MEO5, design of a 200-gallon mixing tank. Our sponsor company is Amodex of Bridgeport, Connecticut. Our faculty advisor is Dr. Aurea Illies, and our sponsor representative is Mr. Peter Dacey. Our mechanical engineering team is Alejandro Figueroa, Anthony Mestino, and Jared Dietermeyer. The problem given to us by Amodex was to design a mixing tank that is twice the volume of the current mixing tank, 100 gallons, without forfeiting the quality of the stain-removing product. Some limiting considerations include cleaning access, motor power requirements, and vibrational reduction. Here's the composition of the current Amodex mixing tanks. They are two twin 100-gallon tanks with agitation motors mounted on top, supports to the wall, and have 4 support legs each. The current design features that each of these tanks have include an offset mixing shaft, which is 1/6 diameter offset from the centroid to prevent vortexing, a bad mixing quality, a slanted bottom, a side outlet valve on the lowest slant, a half circle mount for the motor, and a shaft length that is approximately 1/3 of the tank's height. Through our research and simulation data, we arrived at this final tank design. The mixing shaft still utilizes a 1/6 diameter offset from the centroid. The slanted bottom of the tank has now been replaced by a rounded bottom and now employs a bottom-centered outlet valve for more uniform funneling of the finished product. The anchoring support legs will replace the wall supports previously shown. This tank still uses the same motor and half-circle motor mount design. Some key dimensional increases include the tank height, tank radius, and shaft.
The potential impeller heads that can work for our design are the two shown in the pictures. On the left, we have a 3-angle pitch blade impeller, and on the right, we have the 4-angle pitch blade impeller. In addition to these two impeller heads, we know that the actual impeller head used in the 100-gallon tank is functional for tanks up to 500 gallons. We are letting Amodex decide whether they would like to change the impeller head for one of the new potential designs.
Attached below are some animations of tank simulations from earlier in the year. The left animation depicts the startup of the original tank. As the impeller gains speed, small vortexes travel upward and begin to grow larger. They'll continue to move until they collide with one another. As the mixing process continues, particles will be forced throughout the tank by turbulence. The animation on the right depicts the surface of the mixture as the impeller starts to rotate. As the impeller gains speed, the surface layer will experience turbulence as the mixture folds over itself. In the simulations with the new tank, there weren't any stagnant zones or areas where the contents would rotate in a single direction. This could be attributed to the height and offset of the impeller.
We were able to successfully design the 200-gallon mixing tank without significantly increasing the height of the current tank, taking into account access for cleaning. In our final design, we add features such as a rounded bottom and a bottom-centered outlet valve for efficient and uniform funneling of the final product, and also to improve the drainage of the tank. The rounded bottom also facilitates the cleaning process, as no remaining waste of the mix will get stuck on corners. The current motor is powerful enough for our design, so the company will not have to worry about buying a new motor. As for vibrational resonance, the addition of anchored support legs and offsetting the impeller 1/6 of the centroid will help prevent this occasional vibration the current design experiences.